All right, so this video is going to be on solving rational equations, and basically you don't really have to watch the examples on this. If you know how to add and subtract rational equations, you just need to follow these rules. So after the minute of my explanation, if you understand the rules, then you're literally good to go. You just have to make it happen. If you want to watch the example, stay on for the ride. So first things first. So here's your first rule, okay? So it's kind of like a theorem here. So if A over B equals C over B, okay, oops, sorry, I didn't write that. Okay, then A must be equal to C. So basically what this says to you that if you have common denominators, right? So if all your denominators are common, then the numerators in this case must be equal. So let's look at if we add, right? So if you have A over B plus C over B, and we're claiming that that's equal to some D over B, then, okay, then what will be true is A plus C must equal just whatever D is. So what we're claiming here for this problem is that if your denominators are the same, then you can rewrite your equation, you can take it out of rational, and you can simply write it as a regular mathematical equation. So that's the key to all of this. The key to all of this is you solve rational equations by creating common denominators. Okay? So let's go ahead and show you some examples of this. So here we go. All right, so first example here, kind of minor, not too crazy, all right? These obviously can get harder. I'm just giving you the instructions on how to do it, but the goal of this is to have common denominators. And once you have the common denominators, you then can just write an expression with all your things equal. So here we go. So the first thing is I have a 3, an n, and a 6. So the common denominator here, okay, you have to have it across the way. So the common denominator here is going to be what factors match, and the 6 can be written as 3 times 2. Okay, so basically you're just going to make it so that they'll all have the same factors. So I'm going to get rid of that 6 for a second. So obviously now I have a 3, n, and a 2. Those are my factors that everything needs to have. So the last one just simply needs the n. And the middle one needs a 3 and a 2, so you can just write that as 6, right? 3 times 2. And then this last one needs a 2 and an n. So my common denominator is 6n. Now I'm writing that because whatever I multiply the bottom by, you must inevitably multiply the numerator by. So this 4, okay, must get multiplied by 2n. So I have 2n times 4 all over 6n. Minus, so the numerator must get multiplied by 6, so 7. So this is 7 times 6 divided by this 6n. And the last one I have to multiply by 2n, so that equals 2n all over 6n. Okay, so finishing this off, once all the denominators are the same, I'm now allowed to follow my rule. So my rule I can claim is that 2n, so times 4, which is 8n, so 8n minus, and 6 times 7, so I'm going to put in parentheses, is a 42, must be equivalent to 2n. So the last thing I can do here for solving is I can just go ahead and solve them. So what I'm going to do here is I'm going to subtract 8n from both sides, and I will get negative 42 is equivalent to negative 6n. And then I can just solve this like normal, so divide by negative 6, divide by negative 6, and you will get the final answer is n will equal 7. So what you've now proven is that these two functions, they're equal at n equals 7. All right, next example. All right, next example here. So obviously a little bit more complicated, but here we go. So first off, when dealing with variables, you always want to put it in factored form to see what you're working with. So I'm going to write the denominator of the first one in factored form. So I'm going to write this using a GCF as c times c minus 4. The bottom here is c minus 4. And the other one over here has a factor of 1 in the denominator. So don't forget your whole numbers, they have a factor of 1. So here we go. So this second group has a c minus 4, so it needs a c. So this will need a c, so I'm going to give a c to the top as well. And over to the right, this needs a c, and it needs a c minus 4. So multiply top and bottom by c times c minus 4. And now from here, okay, I'm just going to rewrite this expression. The bottom over here doesn't need anything, so I can rewrite this now as 3c minus 2 is equal to, all over c times c minus 4 is equal to, so c times c is c squared all over c times c minus 4 minus And then I get this problem here, which is going to be minus 1, so c, oh, sorry, oops, my bad, wrote a negative sign. So this is c times c minus 4 all over c times c minus 4. So then from here, all I'm going to simply do is then I can go ahead and get to my solving skills. So the bottoms are the same. So here we go. I'm going to get rid of this. And I'm going to write this as 3c minus 2 equals c squared. Now, you just have to be careful when you have a negative, right? Just make sure that you're distributing that negative. So this is negative c times c minus 4. All right, so the reason I like to write it in factored form is because I'm naturally now going to distribute that negative. For c, you might forget to distribute that, but in this case, I'm not going to forget to distribute it. So here we go. So this problem turns into 3c minus 2 equals c squared. Distribute that negative c, turns into minus c squared and plus 4c. And then from here, I'm just going to keep going, simplifying and solving. So c squared minus c squared is 0. And now I'm left with 3c minus 2 equals 4c. So I'm going to go ahead and subtract 3c from both sides. And what I'm left with is an answer of negative 2 equals c. And that's it. I'm done. Now, if these problems turn down in the quadratics, right, so if you get down to the point where, in this case, my quadratic terms canceled, but if my quadratic terms didn't cancel, you have to think back to how it is that you solve a quadratic. And the way you solve quadratics is either by doing the quadratic formula or by doing factoring, okay? So if you get a problem that reduces down to having quadratics in it, just make sure that you know that you solve a quadratic by either solving by completing the square, doing the quadratic formula, or by factoring if possible. So if it's not factorable, you can go to completing the square or you can go to the quadratic formula, whichever you find easier for you to do. So I hope that helps. And if you want to see one where it goes into a quadratic, just leave a comment in the video and let me know that, hey, I want to see one where I have to solve a quadratic at the end. For these ones, I just had linears. So if you want to see it, let me know. I'm happy to create an example of that for you. All right, have a good one.